Well, it's turning out to be a nice day today in San Luis. So I hope it's a nice day wherever you are. Let's continue on with chapter 2 and look at 2.2, which is absolute value equations, or I guess functions. Okay, so in chapter 1, we dealt with doing some graphing. So we're going to look at some more graphing here just to get that back into the groove. So we'll just do maybe 2 examples of graphing here. So let's talk about graphing. And the idea is as soon as we put up the words absolute value, the hope is that that V comes into your mind. So if I asked you to graph 2 times the absolute value of x minus 3, that absolute value should mean that you're looking at that V, and then we need to decide what these other 2 things are going to do to it. Okay, so if we draw our graph, remember that base function that we've got going on there is that V. So in this case, we've got 2 things that we need to do to it. This negative 3 in with the x in the absolute value is going to be our horizontal shift, but it's actually going to shift us not negative 3 this way, but negative 3, so in the positive direction. This is the one that works backwards. So we'll say like there. Okay, and then we know we've got a graph now that's out here, but this 2 out here is going to give us that vertical or, vertical stretch or shrink. And because it's 2 and bigger than 1, it means that we are going to stretch this. So we're going to put our finger right down here at this kind of vertex area, and we're going to stretch and pull up on it, which means that our graph is going to come in like that. So we're going to be given a, what's wrong?
It says cannot verify server identity.
Is it even recording? That would suck if it's not. It's here, it's right here. Okay, sorry about that. I hope everything worked okay on my end. It's just, okay. But thank you, Ginger, for helping us out there. Okay, so we've got the use of our transformations to move our graph around. Now, as I'm doing this up here, I realize that you just spent a whole section doing this, so I think just one, just to get us back into the groove, is okay. So what we really want to do in this section is we want to solve some absolute value equations. And we're going to use this visual of the graph to help us out. So let's solve equations. And we'll start off with just the most basic. Let's say we have absolute value of x equals 2. Okay, now, if we want the absolute value of x, so the x is inside the absolute value sign, to be equal to 2, what we need to remember is because both sides of this graph are going to be positive, yes, the easy one there would just be to say that x will equal 2, for sure. But if x equals negative 2, are we also going to get a positive answer? So because absolute value makes things positive, when x is equal to negative 2, we will also get a positive answer. So what we actually end up with is like 2 little problems. So, and that's kind of our method for solving here, is that whenever we're given an absolute value, we're going to rewrite it using 2 littler or sub-problems, you might say. So that's the most basic, but let's see one that's really working here, okay? And again, not too hard to start us off with. Let's say we have absolute value of x minus 4 plus 5 equals 11. Now, the first thing that we want to make sure that we do, even before we split it into 2 pieces, is we want to make sure that the absolute value is alone on one side and all the numbers are on the other side. So we're going to leave this absolute value here, but we're going to subtract the 5. And then have the absolute value of x minus 4 is equal to 6. So absolute value by itself equal to a number. Okie dokie. Well, now that we're in this position, we can create both of these two little guys. So we can say that x minus 4 is going to be equal to negative 6, or x minus 4 will be equal to positive 6. Okay, so we're going to solve two sub-problems there. And in both cases, we're going to add 4. Add 4, add 4, add 4, add 4. But don't get lazy. When you add 4 on this one, the answer is going to be negative 2. But when we add 4 on that one, we're going to get a completely different answer. When we add 4 on this one, we're going to get 10. So we get two answers, negative 2 or 10. All right, but that's the method going on here. So let's say that it looked, let's see what we have this time. Let's say that we had 2 times the absolute value of x minus 3 equals 4x plus 6. And this is the guy making it bigger and uglier here. This is the guy that we want to solve this time. So we want that absolute value alone, so we want to get rid of the 2, and we can't distribute in. The absolute value is like fences, we can't go in there. So we're going to divide by 2 and divide by 2, first and foremost. And we have the absolute value of x minus 3 equals, and now both of those guys will divide by 2. So we're going to have 2x plus 3. Now here's where this one honestly gets ugly, because now we have this absolute value, but what we have over here is a little bit uglier. So the first sub-equation, if you will, that we write is going to be, not going to be that. It's going to be x minus 3 is equal to negative whatever's on this side. Or we're going to have x minus 3 is just equal to whatever that side is. Now, do you see how in this one, it's important that we do the distribution there? Okay, so again, this negative side is not going to be the same as the opposite side. This one is going to be a bit on the bigger and uglier side. So we're going to go x minus 3 equals negative 2x minus 3. Now, looking at the minus 3's, they're going to cancel each other out. And if we add 2x, we'll have 3x equals 0. So on this one, x is going to equal 0. Okay, well that's all right. Now over on this side, we're not distributing in, so we can immediately start to move things back and forth. I think I'm gonna move x over this way. And then at the same time, I'm gonna subtract the 3 over this way. So we'll have negative 6 equals, and then we just are left with a single x. So on this one, we get 2 answers. X is equal to 0 and x is equal to negative 6. So 2 answers again. Okay. So one more. This is a quick little section. One more here. Let's say that I gave you the absolute value of 3x minus 1 plus 7 is equal to 5. So using what we've been doing in the last couple, the first thing to do is to get rid of that 7, okay? We want this alone, get rid of that 7. So we're gonna subtract 7. And now we'll have negative 2 over here. Now, it's at this point where if we were in class, I would stand here and talk a little bit and see if anybody raised their hand or thought this through or anything, but as you guys are not here in front of me, we're kind of at an impasse. So what happens is you get into the habit of just splitting it into 2 equations and solving, splitting it into 2 equations and solving, blah, 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 without thinking about the function itself. And that's where this comes into play and us thinking about the function and the graph. Is this guy ever going to be negative? Absolute value is not negative. So can this ever happen? And it can't. Okay, so we can't be negative. So even though you might be tempted to just split it into two problems just like we did over here, because when we simplified, we ended up with a negative on this side, we're kind of out of luck. So we're just going to leave it and we're going to say, this one doesn't have a solution. So we're going to say no solution. And that's definitely the case, but it's easy to overlook. So everybody understand that this one has no solution because when we simplified it, moved that 7 over, we ended up with a negative on this side and the absolute value can't be negative. Okay. All right, so there we go with 2.2, just like I said, a short little quick one. All right, and we'll come back with 2.3 in a minute.